The secrets within these pages, especially under electromagnetic forces, are truly fascinating. Let's explore the motor effect together.
The unseen dance, understanding electric current. What if I told you that the electricity powering your phone, your lights, your entire modern life is nothing more than a microscopic dance of invisible particles? We use it every day. We pay the bill, but do we truly understand it? My name is Glenn, and on the Gilded Ledger, we are about building knowledge and building wealth. Today, we are diving into the absolute bedrock of electrical understanding, starting with chapter 1 of this timeless classic, Electricity Made Simple. We are going to uncover the unseen dance that creates electric current, the atomic solar system. To understand current, we have to start at the smallest possible scale, the atom. Very, very tiny, small particles. Think back to basic science. Every single thing around us, including this copper wire, is made of atoms. An atom is like a tiny solar system. In the center, you have the nucleus, which contains protons and neutrons. For our purposes, the key takeaway is that the nucleus carries a positive electrical charge. Orbiting this nucleus are even smaller particles called electrons, and these electrons carry a negative electrical charge. Crucially, in a balanced neutral atom, the number of positive charges in the nucleus perfectly matches the number of negative charges from the electrons. It's a perfect, stable equilibrium. The magic of the free electron and the copper story. Now, yes, the science of electricity truly begins. Not all electrons are created equal in an atom. Some electrons, especially those in the outermost orbit, are not held as tightly by the nucleus' positive pull. Your book highlights the perfect example, copper, a copper atom, as shown in our book's diagram. Single electron in its outermost end shell. This end shell electron is like a loose cannon. It's easily dislodged when it gets a little nudge, say from another atom's electron. It can break free and wander independently through the matter. We call this free electrons or loose electrons, and this is the fundamental difference between a conductor and an insulator. So we wearing boots, that's insulator, our safety boots, and conductor is the copper that allows passage of electricity, or a open door. When you go into a door, that's a gate that allows you to pass through, just like this. Metals like copper, silver, and gold are fantastic conductors because they have an abundance of these free electrons. They are essentially highways for electricity. Metals like rubber, plastic, or glass, they are the insulators. These are the insulators. The electrons are tightly bound to their atoms, meaning very few free electrons are available to move around. That's why your electrician wraps wire in a rubber or use an insulated screwdrivers or tools. So yeah, safety first. What is electric current? What is electric current really? They can't just wander aimlessly. Imagine a crowd of people in a busy market. They are moving, but not in any specific direction. They scattered all over depending on the markets, table or like that. So it's just the same as the electrons. So electric current happens when these free electrons are organized. When we apply an electrical force, what we later call the voltage, 250, 260, 240 volt, or 415 altogether. When we apply an electrical force, what we later call voltage, we give those free electrons a push. They stop drifting randomly and start moving in one definition direction. That organized direction flow of electrons through a conductor, that, my friend, is called electric current. It's the unseen dance where every electron is moving effectively in synchronization. The book explained that the size of this current is determined by the rate of flow. Literally, how many electrons pass a given point in the wire every single second. We measure this rate of flow in units called amperes or simply amps. The Gilded Ledger application and why it matters. Now, why does knowing this foundational science matter for the Gilded Ledger? Because every single connection I make, every circuit I design, whether it's powering a remote building or setting up a digital office, relies on this exact principle. Understanding the why behind the how gives you an unparalleled advantage whether you're an aspiring electrician, a smart homeowner, or someone looking to invest wisely in the future of energy. This isn't just a theory, it's the invisible force driving our economy. So what makes those electrons flow? What controls the push? That's what we'll uncover in our next video as we dive into chapter 2, resistance and the fundamental relationship between current voltage and resistance of Ohm's law. If you find this insightful, hit the like button, subscribe to the Gilded Ledger for more practical wisdom, and tell me in the comments what electrical mystery have you always wondered about. Let's keep building, let's keep learning.